Okay, I will take this in English so that everyone, even my mentors, will understand. So I would like to start by asking, is there anyone here that has never used the internet? No. Is there anyone that does not own a mobile phone? Okay, that's what I thought. New technologies or modern technologies, they have a tendency of reaching out to everyone who has the potential of getting access to them. And that's a good thing because we want our society to develop. And the reason for why I asked about internet and mobile phones is that they are ways of communicating and transferring information. They are also called telecommunications, communicating via technology or modern technology. And another example of that, or another example of something that can be used for telecommunication is ring resonators. But that's only one of many different ways of using these devices. So I assume that most of you have never heard of ring resonators before. And if that's the case, then you're in the same situation as I was in 4 weeks ago. But through work, both practically and theoretically, I discovered these devices and I gained knowledge about them. And I want to tell you about it. So I will start off by talking about what ring resonators are, then I will explain how they work, and lastly, why they are useful. And throughout all of these parts, I will talk about my project and what research I did. So first off, ring resonators, they are devices that can store and trap light. And there are different kinds of light. There's red light, like this laser. There's blue and green, and even many kinds of invisible light. And what I use is infrared light, which is invisible. But the thing with ring resonators is that they can only store specific light waves. Not everything can be stored or trapped inside them. And ring resonators, they are waveguides, which means that they guide light waves. So if light is injected inside them, it will follow the path of the ring. And as we can see here in the picture, they are rings or loops. But next to them, there's also a straight part. And this entire component is the ring resonators. And they are very small, and you cannot see them without using magnification tools. And the main concept of this is total internal reflection. And that means that the light will be trapped inside of the device, inside of the waveguide. And as we can see here, I've demonstrated light with red arrows. And when it reaches the boundary, it will not continue out this way, out of the material. But instead, it is trapped and it continues propagating inside of the material. And that's the main principle in waveguides. And this is a sketch that I made of a ring resonator. Here is the linear part, and here is the ring. And if we inject light here, it will propagate due to total internal reflection. But when it reaches this part here, due to the very small spacing, light will be transmitted into the ring. And that way, light will start to propagate inside of the ring. But as I said before, only certain wavelengths can stay inside of the ring. So those wavelengths, they will continue to circulate here, while the others, they will leave the same way that they enter and continue out of the linear waveguide. And now, if we want to measure, or if we measure the power, the output power up here, we will only be able to get high results or high signals for the light waves that escape the ring. So we will get something like this. And this is actually a plot of the measures that I made. And as we can see here at these points, the power is much, much lower. And that's due to the fact that those wavelengths, or those light waves, they stay inside of the ring. and that means that they cannot escape, and therefore they are not detected by our device. But if we go back to this picture again, what I've told you now is only true in a perfect world, but there are always imperfections. So out of the ring, throughout all of it, there will be losses. Energy will escape the ring. So there are losses of light out of the ring, and this is what my project has been about. I have calculated the losses of ring resonators. And I did this using all of these plots. I made many different plots and studied them to get to a result. Now, why are ring resonators useful? And to begin with, why is my project useful? What's good with my research? To begin with, if we have a device, we have to know the properties of it, because otherwise we don't know how to improve it. So by measuring the losses, we know where the losses are and what we can do to improve our devices and optimize them. So in my case, I did this study on 2 different ring resonators, one circle and one racetrack. And on the circle one, the losses turned out to be pretty big. And that means that we have to improve our fabrication of our devices. It has to be more specific. While in the other case, in the case of the racetrack, the results did not make much sense. And that's because the losses in that case were not due to the propagation losses, not due to losses escaping the ring, but instead there were losses inside the coupling. And I can go back to this picture. So in the first ring, there were losses out of the ring here. But in the second one, this coupling here was not optimal. So that means that after this study, we know what to do with the devices to get better ones. So the first one, we have to improve the fabrication, while in the second one, we have to change the geometry of it. But in a more general case, what are ring resonators useful for? As I told you about in the beginning, they can be used for telecommunication, but they can also be used for many other different areas, such as detection of chemical substances. And that's because these rings are very sensitive. So if there are any substances on the surface of the ring, the light will escape much more easily, and therefore we will have higher losses. And that way, we will be able to calculate that. And a third thing they can be used for is filtering light, and that's pretty intuitive because that's what they do. They trap certain light waves while others pass by. And in that way, we separate light, specific light from others, and thereby we get a filter. Now, before entering or before exiting, I want you to remember some things. Ring resonators are basically devices that can store specific light waves. That's the basics of them. Then of course there is more complicated things, but that's what you can think of right now. And what I did in my project was to study the losses of ring resonators. And that was to improve their performance and to get a better understanding of how to improve them. And ring resonators, they find applications in various different fields. And who knows what else the future has to hold. I want to thank my mentors for helping me through this research. I want to thank RAISE partners, and I want to thank RAISE for Excellence itself. And of course,